At the command of Fallout, you will hydrate. Fallout! Huh?
That last round was a drool.
Yeah, well, after the day, you'll still be fire team, too.
As in behind fire team number one. To be or not to be laughed at. I predict you will be.
Really? Has Wingo been studying his fruit?
Guten Morgen, Sergeant Mosby.
Good morning, Froy Woodrum. Okay, men, gather up. This is Professor Karen Woodrum. She holds degrees from Royal University in Bochum, Germany, and Biola University in La Mirada, California. She works with the Department of the Army in various ways. But today, she is here by special request to personally brief you lug nuts on how to train safely with lasers. Ma'am?
Thank you, Sergeant. So, let me start by seeing what you know. Well, I see you have an immediate respect for a weapon, even a Miles training system.
Never point any weapon at anyone unless they're to be targeted, ma'am.
Correctly stated. Drilled in use in basic training, no?
As commanded many times, ma'am.
Loudly commanded, ma'am.
So, why is it that we can let you train with these lasers and run around the woods firing them at each other? Sergeant. Anybody? You? You.
Well, come on, Vader. You and Shakespeare ought to have an answer.
Who are Vader and Shakespeare?
Those two. Celebrities from their own episode of Star Wars.
Yeah, I heard about you two. Your sergeant told me you need some assistance with these. Ah, you also know to avoid eye contact with a laser. Very good. So, if you do not know why you can properly train with an infrared laser, why were the two of you playing with a green laser?
Well, ma'am, at the time we thought they were the same.
Harmless. Like the red laser pointers we use to bore sight our weapons, ma'am.
Yes, ma'am, harmless. You know, since we can shine them at human targets approaching security checkpoints and stuff.
Oh, I see. A logical conclusion. For you.
But we recently learned about different classifications of lasers with different hazards, ma'am.
And NOHD, ma'am.
Oh, you understand NOHD.
Maybe.
Well then, would the two of you bring out the canvas that I have behind the Abrams? Unroll that and hang it by the grommets on those stands there. Army Regulation AR 385-63, Department of the Army DA Pamphlet 385-63, Range Safety. Joint Publication JP 3-09, Joint Fire Support. Military Handbook H28, Range Laser Safety. Technical Bulletin Medical 524, Control of Hazards to Health from Laser Radiation. All used by range control to ensure safety during training on their ranges. So, what are they based on? Would any of you like to tell me what all this means? No one?
NOHD.
That is part of it. This math does help us calculate a laser's NOHD, or hazard distance. But it also has to do with how the eye works with light and how lasers affect the eye. Different lasers have different qualities, some more hazardous than others. Researchers took these calculations and simplified them into ways to quickly differentiate lasers by separating them into different hazard classes based on their level of danger during use. This way, we can talk about safety control measures based on how hazardous they are.
Ma'am,
Yeah, a question. I like questions.
It's your cue, Wingo.
well, ma'am, aren't lasers used to correct nearsightedness and stuff in surgery?
Yeah, absolutely.
So, some lasers are good for the eye, and some aren't.
Makes it confusing for you, no? The truth is, all lasers, no matter what class, can be used anywhere, even on the human eye. But only if they are operated by trained personnel who know their laser safety control measures.
Well, ma'am, as a soldier, I just want to know enough to safely use any laser I'm issued, but does it take all that just to do my job?
Why, Kiro? Did your recruiter tell you when you joined the Army there'd be no math? Hernandez, does this scare you?
More than NOHDs, Sergeant.
Anybody else nervous? Good. Listen carefully. Do as you are instructed, and you won't have to learn this. Science. Computation. Sorry, man.
Not necessary, Sergeant. Actually, I wish it wasn't this complicated in order to keep you safe. But as your sergeant said, follow your instructions carefully and you won't have to take a test on this. Now, who can tell me where I can find a laser here on the range?
Mounted on our different weapons, ma'am.
Good. More?
The rangefinders were issued.
Yeah, more.
Well, the tank.
Very good.
Helos?
Yeah, if they were here. And even on a remote weapon station or on top of an MRAP vehicle. So, when you are training or deployed in real combat situations, you may be exposed to a variety of lasers. In combat, there's little we can do. So you rely on your training. But during training, well, there is much we can do. And you too. So, how do we keep you safe? Let's look at the sandbox model we have. First, what is the best control we have available to keep a laser's beam from leaving the range?
Take them away from us.
I'm talking about when you are using them. Like all types of light, a laser beam travels through the air until it hits something. So, how do we do that out here and keep the beam from leaving the range?
Background, ma'am.
Yeah. A natural landscape element like a tree line or a mountain is the perfect stop to a laser. So we call it a backstop, like in your American baseball. And why is this important to a range?
Because it's harder to keep people safe if the range is one large flat field. I mean, it's harder to keep a beam on a range if the range is flat, right?
Jawohl. This model shows how a range takes that into account. Say we are using an Abrams tank, and the targets are over 700 meters away. Notice the backstop of mountains and trees to keep the laser from shooting off into infinity. Or the CEO's house.
Same as any shooting range, a dirt mound stops the rounds.
Exactly. This is the greatest control we have out here. But what do we do if there are no naturally occurring backstops?
Make them.
You're gonna make a mountain, Wingo?
Yeah, you cannot make a mountain. So, what else could you do?
Limit the direction lasers can be used in, away from people who aren't involved?
Yeah, limit a laser's line of sight away from occupied areas on or off the range. But what else could we do?
Change the lasers that's used.
Ah, good. But how?
Use a laser with an NOHD shorter than the range boundary limit.
Precisely.
But I thought a laser shot a beam like forever, ma'am.
That's true. But if you are positioned past the NOHD for a laser, it's safe to be exposed to the beam.
How can that be for us when we're training, ma'am? We're shooting Miles lasers at each other at close range.
Miles lasers are designed to have short hazard distances, 10 meters, which is less than where most engagements take place. And most other lasers have a training mode, which lowers the power of the laser beam, making the NOHD shorter.
Which means we've been running around using the
Training mode, yeah, that is right. Very good. Yeah, but still, accidents can happen. So, after backstops, limiting line of sight, and using training mode, what else do we need to consider?
Lasers reflecting off of objects?
Jawohl. Some objects downrange can cause a mirror-like reflection. Very dangerous when it comes to lasers. But would you find such surfaces out here on the range?
I guess it's possible for a mirror to be out there, like on a Humvee.
But do they occur naturally out in the dirt in the trees? How about here? Suppose you were sitting right there on that mountain over there, minding your own business.
I'd be hit by the laser. But would a reflected laser injure me, ma'am?
Anybody?
Come on, Shakespeare, you should have an answer. How about you, Darth?
Well, according to Major Lucas's story, yes, ma'am, it could.
Precisely. It is still a laser emitting a beam. Only distance could help you. So, if the distance from the laser to the lake, plus the distance from the lake to your position on the mountain, totals less than the NOHD for that laser, you could be injured. But if the distance is longer, you are safely out of range and will not be injured. What if that were you standing beside that lake?
Same thing.
But how do you know what sort of laser hit you to know the NOHD?
I wouldn't, ma'am.
And that is why reflective surfaces are eliminated from a laser range whenever possible. Class 1 and 2 lasers are not the fear, but Class 3R, 3B, and 4 pose a reflection hazard to be taken seriously.
Does that mean tanks shouldn't be allowed on the range, ma'am?
No. You are supposed to train like you fight. Therefore, some reflective surfaces cannot be removed. But wherever they are located downrange, needs to be designated for you prior to any training exercise. And during training, if you engage a manned target or one that has a reflector, your laser should be operating in the training mode.
Because in training mode, the laser may be Class 1, or the NOHD is much shorter, keeping us safe should we get flashed by any laser.
Jawohl. Now you are getting it.
But what if you were looking through binoculars?
You'd be really hurt, right?
Not necessarily more severely.
But we learned the higher the classification, the more harm done.
But we are talking about NOHD, the minimum safe distance you can be from a laser.
But binoculars magnify that laser beam right into your eye. It's way more powerful than just looking at it.
But the binoculars do not act like a magnifying glass.
You mean like in Toy Story when Sid, the kid next door, he burns that spot on Woody's forehead? Like, right. What? Oh, it was a good movie.
Anyway, what binoculars do with a laser is extend the NOHD, the safe distance, further out. So theoretically, you could be flashed by a laser through them without injury, but only as long as you are further away than the NOHD for that particular laser required, which is calculated by the power of the binoculars.
More math calculations, ma'am?
You want to calculate an issue with every laser, Akira?
Yeah, not a good idea. Who has time to do math in the field, right?
Not Major Lucas, anyway.
Sadly, yeah. So our range controls also include buffer zones.
Wait, what are they, ma'am?
Additional protection zones around targets for training. Take your right hand. Hold this laser on that windshield. His movement, his unsteadiness, is what we call slew, or pointing accuracy. Rest your elbow and use your other hand to steady it. We can minimize this by use of fixed positions and tripods, much like how his elbow steadied him. This way, all participants have a better idea of where the beam could go. But we also account for a much larger area for targeting. This increases the safety of personnel by restricting them from these buffer zones.
But accidents can still happen, right, man?
Yeah. So, even with all these precautions, we also avoid orienting the firing points on the range toward populated areas. Towns, schools, other tenant activities, or housing areas. And we maintain constant communications during all laser training to avoid targeting conflicts so people are not unnecessarily lased. We also placard the area at all entry points so you know lasers are in use and what classifications they are. Flashing red lights are often used at range entrances to inform personnel of the potential hazard ahead. Laser range entrances may include a sentry who maintains communication with range control.
But wouldn't it be much simpler if we were just issued safety glasses, ma'am?
You mean LEP? Laser eye protection. Yeah. During a training exercise, if someone must be downrange during laser operation and they are within the laser's NOHD, then proper laser eye protection must be issued to you and worn. But at this time, there is no one single LEP that meets the protection requirements of all lasers.
Well, I got my aviators. They have the same tin as a pilot.
Let me see those. Let me be very clear. Sunglasses offer no protection from lasers. LEP is both wavelength and laser output specific. If LEP is needed during training, it will be issued to you with specific instructions for its proper use.
What about NVG, ma'am?
Yeah, there is minimum danger because night vision goggles create an image on the screen so you're not viewing the actual beam.
So that's good.
Yeah, but just as you would not turn on night vision goggles during the day, which would bloom the lens, rendering them useless. The concentration of laser light emitted by the IR pointer on your weapons can also make them temporarily useless. More powerful lasers do permanent damage.
So, you may not be harmed, but NVGs are expensive. And you really don't want me to inform the CEO you trashed him because you thought it was a great idea to use him as LEP.
And the laser could get around the non-wraparound design, hitting your peripheral vision. That is an immediate eye injury. So no matter what, do not use them as protection.
So what eye protection do we get?
As I said, during training, if you require LEP, the Army will issue it to you. But in combat, there is no single LEP that will protect you from all the lasers that are out there.
Seriously?
Yeah, seriously.
We could wear those big old pilot helmets with the face shields.
This is actually a big concern for our aviators. An enemy may use lasers to aim into the cockpit, temporarily blinding a pilot.
But they have the windscreen and the helmet visor, man.
A windscreen won't stop a laser, nor the face shield. And the visor may be tinted for UV protection from sunlight, but not for laser wavelengths. So, like your sunglasses, there is no protection. Besides, just as a green laser splays across a windshield of an approaching vehicle, it also splays across the aircraft windscreen and the visor of the pilot, or any other thing you place on your face as possible eye protection. So, temporarily, the enemy has the upper hand, while the pilot averts his attention and his eyes. Injuries? Possible. A mission jeopardized? More than likely. You don't want that on the ground.
So, pay attention during training. Learn these safety controls and don't rely on your own ideas.
So, ma'am, are we really safe around lasers during our training?
Yeah, you are. Regardless of training or combat, laser safety is maintained through the use of 3 levels of control measures. Number 1, engineering. This means built-in controls such as emission indicators, multi-step firing switches, warning labels, and exit port covers. Number 2, administrative, which means policies and procedures that are instituted throughout the Army. And if everybody practices them, the chances are very good you will never get hurt. The exception is number 3, personal protective equipment, PPE. For lasers hazardous to skin exposure, long-sleeved clothing made from tightly woven fabric provides protection. But LEP in general is only issued during some trainings. However, do not worry about controlling your environment. That is not your job. But what are you in control of?
Where my laser points.
Jawohl. Is this clear with everyone?
Yes, ma'am.
And that goes for your little green lasers as well, got it?
Yes, ma'am.
Very good. Well, Sergeant, I believe we are done here.
So, are we going to be safe with the lasers issued to you?
Yes, Sergeant.
Or will we have to start teaching what's on the canvas?
No, Sergeant.
It's either safety or the canvas. What's it going to be?
Safety,
Sergeant. All right, then. I think we're through here. Thank you, Frau Woodrum.
Bitte.
Okay, man, let's form up. Hold up. Except for one thing. Shakespeare!
Yes, Sergeant!
From now on, you will be known as Corporal Podansky. Take charge of the group and double back time the company.
Yes, Sergeant. Group, attention! Right pace! Forward march! Left, right, left! Double time! Double time! March!